Hello everyone, welcome back to my channel Physics for AP. So today we are going to entering into the new topic, that is the classification of elements, that is the periodic table. So later in nearly to the 18th and the 17th and 18th century, the elements which were known, the scientists has been came to know that we need to arrange the elements in a particular way. That is, the elements which were known at that time, they need to be arranged in a particular order based upon their physical properties and the chemical properties. So that is why, so the classification of elements, why it has came, because to classify the elements according to their physical and chemical properties, and to memorize the elements according to their physical and the chemical property. That is, if we arrange them in a same group or in a particular column, then the element which are having the same physical and chemical properties will be arranged in a same group. Like how we go for a supermarket. Now if you go for a supermarket, we want to buy a soap. So all types of soaps are arranged in a one particular column, one particular group. So they won't arrange the soaps in a different, like Lux in one side and Santur in another side, or Lifebuoy in another side. So they won't arrange it like that. So that means all the soaps should be arranged in a particular column, all the shampoos should be arranged in a particular column, all the groceries items should be arranged in a particular columns, and all the home items like the toothpaste or brushes should be arranged in a particular column. So based upon that, we can easily identify which one we need to select. The same thing also, the elements which have been known, they need to be classified according to the physical and the chemical properties, so that we can identify them very easily. So among the different scientists have made their different roles. So among them, the first one, not we cannot say him as the first, as before there were many scientists like Louis Pasteur. So many other scientists who had divided them according to the metals and non-metals, solids and liquids and gases, so differently. Among them, the first attempt to make a table was Doberneir. So Doberneir, he had proposed a law which is called as a law of triad. So in his law of triad, what he has introduced is, so all the elements, so the elements which are having the similar properties, whether it is a physical properties or chemical properties, whether it is a solid or liquid or gas, or whether it get react with any of the oxygen or any halogens. So based upon their similar properties, so they are being taken three at a time. So are being taken three at a time, like how we see in this table. So this is the law of triad table, so which was designed by Doberneir. So all the three elements which are having the similar properties are taken three at a time, and then be arranged in the ascending order. So ascending order based upon their atomic weight. So based upon the atomic weight, they are being arranged in the ascending order. Like if we take sodium, lithium, sodium and potassium. So we have lithium atomic weight as 7, sodium as 23 and potassium atomic weight as 39, and then be arranged in a ascending order, as these three are having the similar properties. And how are they arranged is, when they are be arranged in the increasing order or ascending order. So the atomic weight of the middle element is the average of the atomic weight of the first and the third element. So this is what we call as law of triad. Tri means three. So all the three elements are being arranged in a particular group. So this is the group A. So Doberneir was the first who came to assign the word called as groups. So the groups A, in the group A we have lithium, sodium and potassium. So it belongs to law of triad, is that we need to see that the element of the first and the third, the first element and the third element, its arithmetic mean should be equal to the second element. That is, like if we take the first element as lithium 7 plus the third element is potassium, that is 39. Now the arithmetic mean, that is by 2, adding by 2, so we get 46 by 2. So on this we get 23. This 23 is equals to the sodium. At the same time also for calcium, strontium and barium. So here we have their atomic weights, and their atomic weights are been based upon the law of triads, as well as chlorine, bromine and iodine. Next, sodium, selenium and tellurium, manganese, chromium and iron. So these are the elements which are having the law of triads, and in some of the competitive examinations they may give in the following the three elements, like in our first option as sodium, lithium, sodium and potassium, and the second option as calcium, barium and strontium, third option as chlorine, bromine and iodine, and fourth option as fluorine, chlorine and bromium. So they may ask like this, and among the following which follows the law of triad. So law of triad is the first one as lithium, sodium, potassium. So this obeys the law of triad. Calcium, barium, strontium. This doesn't follows the law of triad. Why? Because it should be in an order of calcium, strontium and barium. So this doesn't follows the law of triad. Next, coming to chlorine, bromine, iodine. So this is the law of triad. And next, fluorine, chlorine, bromine. As these are in a correct order, but this doesn't follows the law of triad. So that is one of the limitations that we will discuss now later. So this is about the Doberneir law of triad. That is, the element of the atomic weight of the first element and the third element should be the arithmetic mean of the second element, and they should be arranged according to the increasing order of their atomic weights, and their properties should be similar. Whether it is both the physical and chemical properties, the properties should be same, and the atomic weight should be ascending order or the increasing order. So this is about the law of triad. So we need to memorize these elements, that is these orders, as this law is a failure. So we should not consider this, but these are the basics which has given for us the today modern periodic table. So the today modern periodic table, what we are saying is those all came from the basics from the Doberneir's law of triads and the Newland law of octaves, Mendeleev periodic table. So these are all the basics which had been came up to build the modern periodic table. And next, coming to the limitations, when we see the limitation, that is the failures, are all the known elements could not be arranged at that time. So that is the elements which were known, almost 56 elements were there. So all the elements which were known at that time, those elements doesn't follow the law of triad. Only very few have been following the law of triads. So even if you see over here the manganese, chromium and iron also, if you find out the arithmetic mean, how much you will get. So here we have 55 and here we have 56. So the arithmetic mean will be coming as like some 55.5 something we get here. But what is here? We get chromium as 52. So there is some exceptions that and failures for this, and this law has been failure for the higher mass elements like this. So this law has been failure for the higher mass elements, and the atomic mass were not accurate at that time. So at the time of that Doberneir, so the arithmetic, that is the 19th century, the arithmetic weights were not accurately. So as they were not accurately, so as these are based upon their atomic weight, as atomic weights are not accurate, so this is one of the failure for the Doberneir's law of triad. And coming to the fluorine, chlorine, bromine, so as these are in a correct particular order, but this doesn't follows the law of triad. So this is about the Doberneir's law of triad. So triad means 3, which should be arranged in a 3 elements in a same group which are having the similar properties, and the arithmetic mean of the first and the third element should be equal to the second element. Now coming to here, we have a small numerical problem, that is, so here we have the density of the calcium. So the density of calcium is 1.55 gram per centimeter cube, and we have the density of barium, that is 3.51 gram per centimeter cube, and we need to find out the density of strontium. So how can we find out the density of strontium? So by using the law of triad. So as calcium, strontium, barium, they obeys the law of triad. So as the masses of the first and the third mean, the first element and the third element mean is equals to the second element. The same way also the density. So that can be done as the density of calcium plus density of barium by 2 is equals to, we get the density of strontium. So what we can do is we get 1.55 plus 3.51 by 2. So from this what we get here, the calculation 0.5. So 5.06 by 2. So 5.06 by 2, that we get 4.53 gram per centimeter cube. Five, sorry, 2.53 gram per centimeter cube. 5 and 3. So this is how we can find out the density of a strontium by using the law of triad. So this is a numerical. So this, whatever may be in any type of numerical, if the elements follows the law of triad, then definitely you can do this method. Now next, coming to the next classification of elements, the periodic table, which is the Newland law of octaves. So the Newland law of octaves, so a scientist called John Newland, he has been arranged the elements according to the law of octaves. Oct means 8. So let us say what is the law of octaves represent here. So what does the Newland explains about this? So the elements are being arranged in the increasing order of their atomic weights. So they fall into a pattern in which their properties repeat at a regular interval. So the elements are being arranged according to the increasing order of their atomic weight. The same as what the Doberneir has done. The same also here the Newland also has done, that the elements are being arranged according to their atomic weights, the increasing order of their atomic weights. But in Doberneir, what he had done, he had taken 3 elements at a time. But here he has taken into a certain pattern, and that pattern repeats interval of time. So how can we say this, like in our Indian singings, we say sa, re, ga, ma, pa, da, ni, sa. Sa again comes to the first here also. At the same way also we say that the sa, re, ga, ma, pa, da, ni. Next 1, 2, 3, 4, 5, 6, 7. Next the 8th element again comes from the first. That is, the elements which are coming here for the 8th respective over here, these all belongs to the same properties. The same properties. The elements which are coming from up to down, they have different properties. So they have the different properties. So how they have arranged this, here now we have a table over here. So from that table you can clearly see about the law of octaves. So here we have the Newland periodic table starting from the hydrogen. So if we see in the table, we have starting from 1, 2, 3, 4, 5, 6, 7, and the 8th element again comes from the first. As if you see the atomic numbers like 1, 8, 15, they have all the same chemical properties. So that is what the element with the similar chemical properties are to be present along a horizontal row. And if you see in the table clearly the Newland periodic law of table. And here next, when you are coming for the Newland limitations, so Newland was the first to assign the atomic numbers. As if you see the periodic table in that table, so Newland has assigned the atomic numbers for the elements, and he was the first to assign the atomic numbers for the elements. Now coming to the limitations, as if we have just now we have seen in the table that the 2 elements fit into the same slot. So they have been fit into the same slot, that is the cobalt and nickel, and there are some other elements as if we have seen in the table. So the 2 elements are being fitted in the same slot. That means they have given the same atomic numbers. Just like how we cannot assign the same hall ticket number for 2 different students, right? So one hall ticket number for one student. The same also, the one atomic number should be assigned only for one element only. And also the dissimilar elements are being arranged in a same group as the elements which are being arranged in a group. So this we call it as a group. So the properties should be same, but in his periodic table the dissimilar element, that is the elements which have different properties, has been arranged over there. And this periodic table is valid up to the calcium only, and it has been failed for the higher elements, and he did not left any place for the new elements. So the elements which were known about on that time was some like 56 above, but he didn't left any place for the new elements which are upcoming elements. He didn't left any place for that new elements. So today we have discussed about the Doberneir's law of triad. So in this Doberneir law of triad, you need to memorize the that is the statement over here. So statement is simple, just based upon the similar properties. They are being arranged according to the ascending order of their atomic weights, and their arithmetic mean of the first and the third element is equals to the second. And coming to the table, you need to memorize the group over here. The group sodium, lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iron. You need to memorize these groups. And coming to the limitations, these were not arranged in a proper manner. All elements were not arranged, and it was been failed as for the heavier mass atoms. Next, coming to the Newland law of octaves. So Newland law of octaves was also arranged according to the increasing order of the atomic weights, and it falls in a regular pattern of which we call the 8. That is what we call law of oct. Oct means 8. So 1, 2, 3, 4, 5, 6, 7. Next to the 8th element comes again from the first, at which the properties comes for the same. That is, they have the similar properties. And the Newland was the first to assign the atomic numbers for the elements. And coming to the limitations, he has assigned the same slot, which is a failure, and dissimilar elements arranged in the same group. And it is valid up to the calcium only, and failed for higher elements, and did not left any place for the elements. So thank you for your time for spending with me. And if any doubts regarding here, you can give a comment. And the upcoming videos, we will be hearing about the Mendeleev periodic table and the modern periodic table. So thank you for your time.